this module, I'll be discussing the acidic environment, and it describes acids, whether they come in the water, in the land, in the soil, or in the atmosphere. And what we've found is that due to human impact, these acids have actually increased in concentration. And this is what this module is looking at. So we'll start with indicators. And for this lesson, I'll be talking about acids, bases, and neutral substances. So what we can see here is universal indicator showing different colours at different pHs. So let's start by looking at acids. Now an acid is defined as a proton donor and it has a sour taste. So if you see by the picture you can see orange juice and a lemon. That's citric acid and it does have a sour taste. Other examples are sulfuric acid and a car battery, which is also containing an acid, and vinegar, which is also an acid, which I'll go on to discuss. But just to discuss proton donor, a proton you should always think of as a hydrogen atom with a positive charge. That's what we call a proton. Now many acids occur naturally and they've been known for hundreds of years, such as your citric acid and your vinegar. So starting with vinegar, CH3COOH is the formula, and it's called acetic acid or ethanoic acid. And this COOH, to draw that, is a carbon bond with a double bond to an oxygen and a single bond to an OH or hydroxyl group. So this whole group is called a carboxylic acid group in organic chemistry. So vinegar, it's a weak acid, and it should be because we eat it. If it was a strong acid, I don't think we should be eating it. It's used in cooking, it's used as a preservative. So before we had fridges and things like that, they'd use vinegar to preserve their, like pickling, vegetables, meats, stuff like that. It stops the growth of bacteria and other microorganisms. And it's also a natural cleaning product. So another acid, citric acid, which is found in lemons, limes, oranges. It has the formula C6H8O7 and the name 2-hydroxypropane, 1,2,3 tricarboxylic acid. Now, this is the structural formula for citric acid. It's a weak acid again because we eat it, we drink orange juice and so forth, citrus fruits, and it's used to add flavour to foods. Now, with the name, as you can see, carboxylic acid, 1,2,3 means there's 3 of them. And if you remember, I told you that's your carboxylic acid group. So where are they? Those are the 3 carboxylic acid groups. So now we name the carbons. 1, 2, 3. 1, 2, 3, tri, meaning 3, carboxylic acid. There's one there, there's one on 2, and there's one on 3. 2-hydroxy, meaning a hydroxy group is an OH group. So 2, meaning we have an OH group on the second carbon. Okay? So that's how you systematically name organic compounds. So just going back to that slide, I'll just remove what I've written so we can keep going. Okay, so moving on to ascorbic acid, which is vitamin C, which we all need. It's vital for our immune system, it's good for keeping off colds, and it's found in citrus fruits. So citrus fruits are actually very good for you. Not only do they contain citric acid, but they have vitamin C as well. But green leafy vegetables as well, very, very good for you. And lactic acid, which is found in milk. C3H6O2, 2-hydroxypropanoic acid. Again, oic acid has one of these groups. And there it is. There's the formula. That's your carboxylic acid group. Okay? So it's found as different isomeric forms in milk and also in muscle tissue. Okay, so other examples of acids now. The stomach produces gastric juices, which contain hydrochloric acid, HCl, which provides an acidic environment for the digestion of proteins by certain enzymes and also to kill microbes. So the pH of our stomach is actually approximately about 5.5, and that's in order to break down what we eat and what we drink. And other acids used in laboratories include sulfuric acid, H2SO4, nitric acid, which you can see in that picture there. That's nitric acid, and the brown gas is nitrous oxide coming off, which I'll talk about in the next few tutorials. And hydrobromic acid, which don't occur naturally. They're actually synthesized in a laboratory for laboratories. And they're very strong acids too. So these and many naturally occurring acids are manufactured extensively by the chemical industry for various reasons. So, acids have many important applications in industry. They're used in the manufacture of plastics, fertilizers, drugs, and explosives, such as that pretty picture of fireworks over Sydney Harbour. They're an important catalyst for many reactions also. So they're widely used in the chemical industry because they speed up certain reactions that may take hours or days. If we add an acid, sometimes it happens faster, so things get done faster. So let's look at some examples of some acids. HCl, hydrochloric acid, used by builders to clean bricks, cement, and tiles. Also used as a catalyst in the laboratory, and also used with chemical synthesis to add a chlorine group. So HCl has many wide applications. H2SO4, sulfuric acid, used to make fertilizers. It's an electrolyte in car batteries, as the picture you saw before. That's sulfuric acid in car batteries. It's used for the manufacture of soaps and detergents. H2CO3, carbonic acid, found in soft drinks and other carbonated beverages. And that's where you get the fizziness of the carbon dioxide from carbonated beverages. And it also gives a slightly acidic taste in soft drinks. HNO3, nitric acid. It's used in the production of pesticides, explosives, dyes, and drugs. It's very much monitored by governments because it is a very strong acid, and when used as an explosive is very, very strong. And finally, acetylsalicylic acid, which is the main component of aspirin, which you take when you have a headache or you have a pain. So looking at bases now, we've just talked about acids. Now I'll talk about bases. They're also encountered in everyday life. They're used in a variety of household cleaning agents, for example, oven, drain, and window cleaners. So here's a few examples. Sodium hydroxide would be the first base I would think of if someone asked me, name one base that you know of. I would say sodium hydroxide. Whenever you see a hydroxyl group, OH minus, always think base. Whenever you see H+, think acid. That's the easiest way to remember. Base, acid. So sodium hydroxide is also called caustic soda. It comes in pellets, as you can see in that picture. It's used for making soap and some synthetic polymers, and also alumina, which is used in the mining industry quite widely in Australia. It's used for drain and oven cleaners. So it will clean out sinks and blocks drains. It's actually very, very strong. Most people think that acids are stronger than bases, but actually if you get very strong sodium hydroxide, it's actually stronger than acids. So there's something to remember. And it's also a chemical reactant in the laboratory. Another example, sodium carbonate, NaCO3, also called soda ash. And sodium carbonate 10 water, which is sodium carbonate with 10 waters attached. So this is called washing soda. The reason for these 10 waters is if the atmosphere is quite muggy or humid, waters will attach themselves to NaCO3. So you wouldn't normally find NaCO3 in this form unless it was under conditions where there was no humidity. So this is how we get this formula. So both of them are used as a water softener during laundry when we wash our clothes. It competes for the magnesium and the calcium naturally found in water, and it allows the detergent to actually work. If we didn't have sodium carbonate, our washing wouldn't be as clean, basically. So that's what that base does. Another common one, ammonia. I'm sure you've heard of it. It smells horrible, but it's a great cleaning product. So we use it to make fertilizers. Okay, so examples are ammonium sulfate, and also in the extraction of nickel in the mining industry again, and in household cleaners. It's a very good cleaner. Another example, magnesium hydroxide, MgOH2, and aluminium hydroxide, AlOH3, because aluminium has a valence of 3+, magnesium has a valence of 2+, hydroxide has a valence of -1, so that's where we get the formulae, 3 hydroxides, 2 hydroxides. So these are basically used for tummy problems, used as an antacid to relieve upset stomachs and gastric reflux. Because the stomach is acidic, we need a base to counteract that acid, and that's why we use either of these two. Finally, looking at neutral compounds, this includes water, ethanol, and common table salt. So you've got acids, bases, and in the middle at pH 7 are neutral compounds. And always think water, neutral. So that's looking at a few common acids, bases, and neutral compounds. So now I'll discuss a few questions. Okay, question 1. Which of the following is a neutral substance? Now, vinegar, acetic acid, it's an acid. Ammonia is a base. Ammonia is NH3+, that's the formula. Ammonia is a base. Magnesium hydroxide, which I just discussed, is also a base. So our answer is sodium chloride. That's the neutral compound. Question 2. Which of the following is not a basic substance? Our answer there is sodium chloride, because we have a carbonate, sodium carbonate, that's a base. Sodium hydroxide, OH, that's a base. And ammonia, that's a base. Sodium chloride is neutral. Question 3. Which of the following is an acidic substance? Ethanol is neutral. Salt water, slightly basic, depending on where the salt water is, how much salt is in there. Soda ash, basic. Our answer there, vinegar, acetic acid, that's acidic. Question 4. Name and give the formula for some acids found in foods. So we have a few choices here, and I've just listed a few examples. Acetic acid, which is vinegar. CH3COOH, remembering our carboxylic group, carboxylic acid group. Citric acid, with its formula. Lactic acid, found in milk and muscle tissue, with its formula. Carbonic acid, H2CO3. So there's just a few examples of acids that are found in foods. There are many others, but these are quite common. Finally, question 5. Name and give the formula of a base used as an antacid for upset stomachs. A few examples include magnesium hydroxide, which is also called milk of magnesia, which is MgOH2, in brackets, 2 hydroxyl groups. Alka-Seltzer, you may have heard of, which is sodium hydrogen carbonate, or it can be potassium hydrogen carbonate. And Gaviscon, you may have also heard of, which is aluminium hydroxide. So there's a few examples of acids and bases and neutral compounds found in our day-to-day lives.